Revolution machine tool. This machine behind me is our FC-FAB 157.25. Now 25 means quarter-inch mild steel capacity. And the 157 is the max flanging diameter and also max cutting diameter. This machine will flange and also it's a circle cutter with dies. I mean, with the cutters that we supply, you can circle cut with them. Now, we've got a pedestal or a carriage with power to adjust to what we're doing. Now, this type of machine requires your blank to have a hole in the middle, a small hole. It's 0.9-inch hole in the middle of your blank, so you can mount it on the pedestal. I mean, there's another style where we have an O-frame that comes around. We have a hydraulic cylinder that comes down and clamps your material. If you don't want to have that hole in the middle of your blank. Again, it's an O-frame style. This is the C-frame style, which requires a hole in your blank. But this pedestal also powers up and down, get your center height. Also, if you're doing a cone, a different type of part, maybe even already a dished head or something you need to flange on, you're able to adjust your center height for what you're doing. Now, when I'm moving this pedestal, I've got a readout that tells me my position, and I actually can program that or set it to a point if I was, kind of production, the same size head, that kind of thing. Now, this carrier, it's got dual speed, so I can slow it down and fine adjustment. I'm going to bring it in here. This is just a piece of 12-gauge stainless. Notice I've got flange tooling in here. Now, this machine standard is supplied with a 1-inch radius tooling. You can optionally build or supply any radius up to 1 3/8 the full capacity of the machine. Now, if you need a bigger radius than 1 3/8, again, this radius, not diameter, but radius, and say like we were below the max capacity of the machine, the machine has enough power to do a larger radius than that. But 1 3/8, again, this is 1-inch radius, and I'm going to flange this piece of stainless here in a second. You'll see how that works. So, come in. Again, if I did this a lot, I would know my position or where I wanted to be, which is perfect distance and that kind of thing. If I need a multiple step that I could on the part. So my part's level. Now, for alignment between my flanging dies or my circle cutters, I've got a collar here that's locked, and I'm able to adjust the alignment of this lower shaft, the lower spindle. Whatever my thickness is, I'm able to easily adjust that just by turning my collar, changing my blade gap on my cutting dies. Now, also we've got the swing out guide where we're going to set, and then we would lock these and set for our part. Now, there's one in the front, there's also one in the back. I'm going to walk around the back and swing it out. Swing out guides. It helps keep the parts stable. We'll run them. Now this particular machine, I'm going to pull these back because I've locked them. It has variable speed on our flanging guides, and that's an option. Granted, I don't have pressure, my part's not turning, but Got power down on my upper roll, or upper shaft. Now, see with the variable speed option, you can adjust what I'm doing, depending on speed, what type of work I'm doing, how fine I need to be. Variable speed's an option on that location. Yeah, we're going to change the camera setup, and I'm going to flange this part. And I appreciate you watching the video. Thank you.
Okay, so we've moved our guides out and just locked them. It's simple with these bolts, but a friend of mine told me, who does a lot of these, it's not a bad idea to put a timing mark on it. Now, when we get running this, if you're adjusting your top roll, you don't want to adjust it again if you haven't made a complete revolution. Otherwise, you're going to have different yield points in the material. It's going to get out of whack a little bit. So he said, put a little bit of a timing mark, piece of tape or whatever, so that you know you've made a full revolution before you adjust that top roll. But you can see, if I can get this camera set right, but now how far I use my shuttle to come in here, determines, how far, what radius, and what's going to happen here. You can also, radius it, move it in, radius it, move it in, move radius. You can actually step kind of a radius if you can. If you need a bigger radius, but you're kind of limited on how, far down you can go just to the nature of, your dies and the diameter of them. But, yeah. We'll see what happens. I mean, I have not ran a lot of these, so it could be interesting. Some of my service guys have done quite a bit of it, but they're out on installs today, so. But, yeah. I'm going to run this for you. Not adjusting that until I make a full revolution on it. Now if I ran these a lot, I'd probably be a lot more aggressive. Now, I've started that just so I can show you how it works. I'm going to bring in my material a little bit in case, if I needed to for a part. Come down so I've got pressure still to drive. You can hear the machine. Other guys that run these all the time will listen to the machine. Just got to overcome the yield of the material slowly. We can actually adjust the upper shaft to the speed that I come down. There's a metering valve. So if I wanted to come down slower, a little bit faster, I could do it. see that. I'll take some pictures here in a second, but not too bad for a rookie. But yeah. Yeah, what a lot of guys will do, they'll use the machine, power it, and then they'll sand these heads, you know, depending on what they're doing. But yeah, fairly simple if you kind of understand what's going on. I mean, again, there's people a lot better at it than me that have done it, you know, day in, day out, but that's how it's done. But yeah, I'll take some pictures, put in the video, but that's it. Thank you. Okay, we loaded a piece of 1/4 inch. We think it's mild steel. Let's see what she does. Gonna slow this down. Speed up.